let us look at transportation. Pay attention. Let's go. So you will notice that there's a graph there on page 230. You're seeing that? That graph is showing you different environments. So you have a desert environment, you have a grassland environment, you have a forest environment, and it shows you in terms of the precipitation yield that you will have and the sediment that can be transported in the different environments. So you're seeing that. So if you look at desert, can you see that you have a higher yield of sediment because you should know deserts are very dry, sandy, right? Then you have grasslands, and then you have forests. You have more precipitation. You're seeing that in forest and grassland, and therefore less sediment yields in those environments. So the four main transportation processes, again, it is the same, similar to coastal environment, same traction, saltation, suspension, solution. However, remember each of these in terms of the coastal environment, river environment gives you the differences. Yes? Traction in a river, how does that operate? Right, so it is the largest material, so that's what I want you to know. Boulders, cobbles, larger size material. So we're seeing over here traction, and you notice you have boulders and cobbles. That material, when you go to Morang River, in that upper course you're going to see larger boulders, and of course the water is not enough to sufficiently move it. So they kind of like drag or the inch along, as you would see. Everybody understand that? Then you have saltation, where you have now what? Smaller material. So the material of like the boulders, they are broken up smaller, right? And you can now have like a pebbles, and they can, because of the force of the water, and they are now probably in the middle course of the river, they hop, jump along the course of the river, skip. You all understand? So the material can be transported easier. Then you have suspension. So I like to explain suspension when you take, you all know those dissolvable tablets, right? So a reduction or Andrews, right? That can go from suspension into completely solution, right? The difference being in suspension, you still have little sediments in the water being carried. So what you have there, you're going to have, you would see fine particles that are carried along in the body of the water, with the lightest floating on the surface. And you might have things like your silts and your sands. Yeah? That goes straight then into solution that completely dissolves. So when you completely dissolve a reduction, you will see the entire glass of water is now orange. Yes? And you may not have any sediments like in the suspended state. Do you all understand that? All right, great. So let's go on to deposition. Depositional features, we go a little more in detail because we look at deposition in relation to the velocity within the river channel, right? And velocity has to do with the speed, right, and the amount of discharge in the channel. So we have something called the Hillstrom curve, and you all see the Hillstrom curve there, and it's just showing you that intersection between particles transported, particle deposited, and where erosion is in terms of the river velocity, which you all can see there, and then diameter of particles. Of course, you would see where particles are deposited, you're seeing that steep part of the graph towards your right, you're seeing it. That shows that there's more deposition of the cobbles. What are you seeing? Cobbles, pebbles, sand, and it stops at silt. Very good, it stops at silt. Right? Then you look at transported. What is easiest to be transported? What you're seeing there? Clay, silts. Then when you get to gravel, you'll see it becomes narrow. Are you all seeing that? Narrow. And then where cobbles is, you would notice that it's a dashed line because, of course, it's harder to transport. And then you have that eroded particles, right, where you see sand, silts, silts, sand, and gravel becomes the most eroded part as opposed to the cobbles and the pebbles and clay. Why do you think clay is not eroded that easily like sand and silt? Because it holds water, and remember clay, that material is very hard to dissolve. Remember, it gets very gooey, tacky. You all understand that? So that is the Holstrom curve, and the deposits again transport in terms of size and deposit. So you have, of course, cobbles and boulders. What is the size of cobbles and boulders? Look at the size of it on the graph in terms of diameter of particles. 10, 1,000, right? And then you have pebbles between 110, you all seen that? And then you have gravel, right? Then you have sand, silts, and clay. Does everyone understand that? Right, so your projects are to go through your erosion